Hey, so today I'm going to go through the notes for day 6, and it's the applications for log and exponential graphs. Right now, a graph like this is big in the news that you should recognize that one. This is the coronavirus. It has an exponential curve, and so you always would say, what are we going to use this in real life? Well, this is real life. This is what we're going through. This is why we're staying at home right now, because we're hoping that we can stop this exponential growth and flatten the curve. So that's kind of what we're doing right now. So the coronavirus is following an exponential growth pattern. All right, so we're gonna do word problems today that have to do with logs and exponential equations. I'm gonna go through these real quick. If you have a sheet of paper, you might wanna write some of this down, or you can pull it up from Canvas or something, but you're gonna need these formulas whenever you're doing your math lab, okay? And a couple things that you might wanna see is this first one. This is the first formula in your notes. This one is for compound interest. You're gonna know you need this formula, this one right here, if it says it's compounded and they give you a certain amount of time, compounded quarterly, compounded annually, compounded monthly, something like that. They're gonna tell you how often it's compounded. That's the way you know to choose this formula, okay? There's another one that is the one right next to it. A equals PE to the RT. I'm gonna write that right here. A equals PE to the RT. This formula right here is only used if it says it's compounded continuously. So you use the first compound interest formula, this one, if they give you a certain amount of time that it's compounded, quarterly, monthly, something like that, it's gonna say the word continuously. And if so, they want you to use this formula, PE to the RT. Okay, so I'm gonna go through real quick what all of these variables mean. P, that stands for the principal, the amount that you put into the bank or invest, whatever, that's the P. The amount, I always think of it as what you put in, okay? R stands for the rate. That's a percentage. So R is the rate. You're always going to change the percentage given in the question to a decimal. So 5% would be 0.05. Move your decimal back 2 places. Okay. N, this is the one about compounded. It's going to say it's compounded quarterly. Then the N would be 4. If it says compounded monthly, the N would be 12. If it says compounded yearly, the N would be 1. So however many times it's compounded, that's what you put here for the N. And if you notice, there's another N. You put it for both of those spots. So these two numbers are always going to be the same, okay? T stands for the time in years, okay? So if it says over 3 years, you would put a 3 right there, okay? This one, for the continuous formula, again, P is the same as up here, the amount that you invest or the principal. That E, that's the E button on your calculator, all right? So that's not a variable. That's a number on your calculator. You're going to use the E button, and I'll show you where that is when it comes up in the problem. R again is your percent, change to a decimal. T is your time in years. Okay, so these are the two compounding formulas. Then we have the next two on your notes. Those are half-life and doubling time. And these formulas are used in a problem where it tells you you're trying to find how much of something is left over, and they give you the half-life, or it'll say the population of something doubles in a certain period of time. You're going to use this. So it's going to be obvious in the question which one of these to use. I believe both of these are asked in the math lab, so you're going to need to make sure that you use the right one. They're very similar to each other. Half-life has a 1/2 right here. Doubling time has a 2 right there. That I0, I wrote it down here. It means the initial amount. You've probably seen a formula that has that in it, maybe from physics or something. T is for time. H is the time that it takes to half. So when you read the question, the H is for the half-life, or D is for the doubling time. So make sure that you don't, there's going to be 2 times given in these problems, so make sure you fill in with the right one. And we have some examples of that in the notes. All right, and then another formula that's not on your sheet, but I want you to add, write down here somewhere, or write it down, or just know it. You're going to need this on your math lab. It's simple interest. I equals PRT. I always remember I party, okay? Principal, the rate or the percentage, and the time. So these are compound interest, and this one right here is for simple interest. All right, so just read the question and see which formula they want you to use. If you click on show me an example, they'll give you the formula, okay? All right, two that are still on here that I haven't used, and we're not really gonna need them, and I don't believe you need them for your math lab, but they're gonna be in the problems, but they usually fill in the equation for you, but I just want you to see about them. There's a formula for exponential growth and a formula for exponential decay. In algebra 2, you probably saw this as like A equals P times 1 plus R to the T power, something like that. But these are two other examples. And exponential growth, this kind of formula right here is what you see modeled by this equation right here for the coronavirus, okay? All right, so let's go through the problems. I'm gonna tell you how to set them up. I'll probably show you how to type a couple of them into the calculator, but then other than that, I'm just gonna write the formula down and assume that you can type them into your calculator okay. And if you have questions, then ask me or ask your teacher if you need help getting them into your calculator the correct way, all right? So this first one, you read the question, if interest is compounded monthly. So when you see that right there, that's your clue. Compounded monthly, we need the compound interest formula from up here, that one. So our formula, and I would suggest you write it down. So A equals P times 1 plus R over N to the NT power, and then you fill in what you know. $1,000 is invested, that's the P right here. So I'm gonna put 1,000 times 1 plus R stands for rate, so 9.5% you have to write as 0.095. Change your percents to a decimal. N is the number of times per year that it's compounded. So you get that room right here. It says it's compounded monthly. That means in this problem, N is 12. So you have to put a 12 here and a 12 here. This T right here is your time. So 12 times 5. In your calculator, I would just go ahead, go to make sure you're on your regular screen. So you're gonna go 1,000. You can type this all in at once. Parentheses, 1 plus, the easiest way to do this is to do alpha y equals, so you get your fraction bar. Okay, 0.095 divided by 12. Okay, and then make sure you use the exponent right here. Raise it up to, you could either type in 12 times 5, you could go ahead and call it 60. Whatever, just make sure you're leaving all of that up there as your exponent, hit enter, and you're gonna get the answer, which is gonna be the account balance. So this isn't your interest, this is telling you how much money you now have. You invested 1,000, and in my calculator, I got 1605,009, so I'll say 01. So what that means is I put in $1,000, I now have 1605. So if the question were to say, how much interest did you earn, it would be $605, because this is the amount that I have now, okay? All right, next question says, interest is compounded continuously. So when you see this word continuously, you're using the continuous formula from up here. So problem number 1, I use this one. Problem number 2, I use the one with continuous compound interest. So A equals PE to the RT power. So same thing, principal, we're doing the same problem from before, 1,000 E to the R, which the rate is 0.095 again, times the time period, again, of 5 years. So in your calculator, almost the same thing, 1,000. There is an E button on your calculator right here. If you look at the division sign on your calculator, right above it in blue on mine is a little E, so I hit second, and I get the E button on the calculator. Oops, sorry, raise that up to 0.095 times 5 power. So it should look like that. And I get 160801. So not much difference, but there's a little bit, okay? So make sure you're always reading which formula they're asking for. The math lab is very picky on these. You need to round it correctly. Try not to round until the very end of the problem. It doesn't give a whole lot of leeway if you round it incorrectly, all right? All right, next one. How long does it take 1,000 to equal 1,500 if it's invested at 8% compounded quarterly? It doesn't say compounded continuously, so I need to use the compound interest formula number 1. This one. Oops, R over N to the NT, that formula right there. See that? All right. So this time, 1,000 is what we're investing. 1 plus the rate is 8%. Quarterly, that means 4 times per year. To the 4 times, we're looking for how long, that's the question. So I don't know what this T is, so that's what I put right there, okay? But I do know the answer. I can't have 2 variables, so I must know something else. If I don't know time, I know that I'm gonna end up with $1,500 over here. So that's how you're gonna set up a problem like this when you're trying to solve for something other than the final amount. You're gonna have a variable over here somewhere. The first thing that you wanna do for this, before you do anything else, is divide this 1,000 over here. So divide the 1,000 to the other side. So now I have 1.5 equals this, 1 plus 0.08 over 4 to the 4t. Okay. All right, so now we're to the point in the problem from when we were solving equations. This is like the last day of notes. Whenever you have a problem, even if I work this out in my calculator, I don't know what this is gonna have to be taken to, what power to give me 1.5. So whenever your variable is up here in the exponent and you can't figure it out, this is whenever you log both sides. All right, so when you have an exponent up here, you're gonna log both sides, okay? So what you wanna do is write log of 1.5 equals, I'm gonna leave a space right here, and then you're gonna write log of 1 plus 0.08 over 4, or you can work that out in your calculator if you want to. And instead of putting my exponent up here of 4t, remember how exponents jump to the front from our properties? So you're gonna move the 4t to the front of the equation. So what you can do now, if I'm trying to solve this equation for this, for t, okay? I would probably go ahead and divide this whole entire log of all of that right there, divide this underneath here. So in your calculator, I'm gonna do the log of 1.5 divided by the log of 1 plus 0.08 over 4 is gonna equal 4t. This is where I'm at in the problem now. Okay, so I'm trying to solve it for this t, so I'm gonna divide this to the other side. So in your calculator, I'm gonna go alpha y equals and get the fraction bar. So I'm gonna do log of 1.5 on top, close the parentheses, divided by the log, and you can just go ahead and type this in. You can do all that. I may have put in extra parentheses, we'll see. So I get this number, 20.475 equals 4t. So now you can see in order to solve this problem, I just need to divide that number by 4. Leave that whole fraction up on your screen, I mean that whole decimal. Don't do 20.475. Leave the whole thing on there and just hit divided by 4. That way it's not rounded until right now. So I get 5.119. And then you just need to make sure on your math lab that you read carefully what decimal they want you to round to, okay? Could be whole year, it could be tenths, hundredths, thousandths, whatever. You just need to make sure that you read what place to round to, okay? All right, so the next one, this one has a couple parts to it. Some more room down here. All right, so this one says, they're giving you the equation right here. So this is like an exponential growth equation, but you can see they've already filled in a number. I'm gonna write it again down here. Y equals 4080 e to the kt power, okay? Let's see. In the website's 3rd month, there were 10,000 hits. Find the value of k. So let's do that first. We have to find the value of k. So we need to fill in what we know. We know that when the time was 3 months, there were 10,000 hits. All right, Y stands for the number of hits. So you're going to put 10,000 over here for Y. Equals 4,080. Remember, E is E. There's not a variable. We don't know K, but we know it was 3 months. Okay? So if I want to solve this, first thing I need to do, just like in the last problem, is to divide by the 4,080. So 10,000 divided by 4,080. It's like 2.45. Just leave that number in your calculator. I'm going to put dot, dot, dot because it had more decimals to it. So this is where I'm at in this problem. I'm going to go ahead and write K times 3 as 3K. I don't know what power of E is going to give me this. So when you get to this point in the problem and you can't solve it by just getting the same base or something like that, this is where you log both sides. Anytime that this is an E, instead of writing log of both sides, we're going to write ln of both sides. So we're going to say that ln of that 2.45 number equals, bring the 3K to the front, ln of E. Okay? Then we need to solve this for K. By the way, I want to show you something. ln of E is 1. So if you know about your logs, stop right here for a second. What is the ln of E? E to what power equals E? This right here, the ln of E is 1. If you remember that, then you can just change it to 1 right now and you don't have to use it again in the problem. If you don't think about that and you forget about it, it's no big deal. You can use ln of E in your calculator and you can divide this by ln of E. Okay, so what I'm going to do in here, I'm going to say that I need to do the ln of this number up here. So I'm just going to go up here and highlight it. So the ln of that number divided by the ln of E, which we already know is 1, but if you didn't know that, you could still do it in your calculator and you get this number. I get 0.896. So I have something like 0.896, whatever, equals 3K. So now you're to the point where you just divide that by 3. So I get 0.299. And we are going to go ahead and round this because they needed us to find K. So K is 0.299. So that's the first question they asked for. Okay, so here's the work that I had to do to get that. Remember, at the point in the problem where you get stuck, that's when you take the log or the ln of both sides. The exponent comes to the front, and then you take the log, or you take the ln if you have an E. All right? All right. Let's see. It says, use this result to predict the number of hits the website will have after 24 months. So we're going to go back to the problem. Y equals 4,080 E to the KT. So I have 4,080 E. I know what K is now. We just found it. 0.299 times 24, because we have 24 months. So if you put that into your calculator, 4,080 E raised to the 0.299 times 24, it's going to have about 5,335,281 hits. Okay. So this is your answer for K, and this is your answer for the number of hits. So this was a 2-part problem. Okay. All right. We have a few more on the back, not too much. All right. So the next one, switch my pages here. All right, so this time we have, it says the growth function describes the number of people who have become ill with influenza T weeks after the initial outbreak in a particular community. So this is an example of something similar to what we're going through right now, but this one is for the flu. All right, and they've given you the equation, so we don't need any of the ones on the front side. We get to use that. It says how many people became ill with the flu when the epidemic began. So we need to look at what we have up here. We have 100,000 over 1 plus 5,000 E That says to the negative t. If you don't have notes in front of you, this right here, this formula, 100,000 over 1 plus 5,000 e to the negative t. So this is time. When the epidemic began, that's going to be when t is 0. So always your starting point is going to be at t equals 0. So all you have to do is plug in 0 right here. So if you put this into your calculator, 100,000 remember, clear all this. Alpha y equals 100,000 over 1 plus 5,000 times e to the 0, or we know that's going to equal 1, but you can go ahead and put it in there. So that's what I've typed in my calculator. And that gave me that. If I want to do, I could do 10,000. I think I typed this in wrong. All right, good learning moment. You can go up here and highlight it. I noticed that I accidentally wrote 10,000 instead of 100,000, so I'm going to fix that. So I have that over 5,001. I can change it to a decimal, maybe. Yep. So 19.996. So about 20 people. So I'm going to put approximately 20 people. So right at the start of this flu epidemic, 20 people were sick. But now it says how many people were ill by the end of the 4th week. So we're going to do the same thing. The 100,000 over 1 plus 5,000 e. And remember, it's negative t, so this is negative 4. What I can do, so I don't have to type that in again, I can go up here and I can highlight. And all I have to do is change that 0 to a negative 4. And I have 1,080 people approximately. So 4 weeks later, in this particular flu epidemic, it went from 20 people to 1,080. Unfortunately for our coronavirus, that is not the growth rate. The growth rate's much higher. And so that's why we're having to take all these stricter measures to keep people from getting sick, because the growth rate is a much higher rate. Okay. All right. So number 6. All right. This time it says we're seeing how long it takes to triple its population. It's a growth rate. So we have a formula for growth rate. Oh, they gave us the formula. Sorry. They didn't give you that. You would have had to use one of the growth rate formulas, but this one is given. So T equals ln of 3 over K, and the growth rate is K. So we're not going to put 3.1, we're going to put 0.031. You can just type that into your calculator. ln of 3 divided by 0.031, and you get 35.439 years. Okay, so in this particular case, it's going to take it this many years to triple its population. Okay. All right, next one. This is it's talking about doubling. Doubling has its own specific formula. You notice there's no given formula in here, so you're going to use the doubling time formula from the other side of your notes. So A equals that IO, which is initial, times 2 to the T over D, T over D. All right. So in this particular problem, it says the amount now is 10. So that means 10 goes right here. 2 is given in the formula. It doubles every 3 weeks. Make sure that you use the D for the time it takes to double. So D is 3. And 7 weeks is how long of a time period we're talking about. So T is 7. So make sure you put those in for the right place. Okay, because they're both time frames, so it's a little bit tricky. Make sure you get them in the right one. Make sure the doubling time becomes the D. So in your calculator, 10 times 2 raised to the 7/3 power. You can just type it in like that. You cannot make that 20 to the 7/3. You can't multiply first, okay? Common error right there. So I get 50.397. All right, so that's how many, if bacteria right now is 10, this is how much you're going to have 3 weeks later, based on the growth rate, the doubling time that is given, okay? And the last one is the half-life. So half-life formula given on the other side is initial amount times 1/2 to the t over 8. So these formulas are very similar. You don't have to memorize them, okay? Just have the notes out or pull up the notes when you're doing your math lab. All right, so the initial amount in this problem is 15. There are 15 grams present initially. So I'm going to put 15 here times 1/2. When will there be only 7 grams left? So 7 grams is the final amount. So that goes right there. I know the half-life is 20. So 20 is the H. So when you're setting this up, it's T over 20. The question is when. That's what we don't know. That is the time. So time goes right here. All right, so you're trying to solve this. The very first thing you always do when you're solving one of these problems, if there's a number in front, you want to divide that number out. Okay, so now I have this. I have 7 over 15 equals 1/2 to the t over 20. Okay, you can't divide by 1/2. That's not how you do it. If I'm missing the exponent, that's what I'm trying to solve for. This is the point in the problem where you log both sides. So I'm going to say the log of 7/15 equals t over 20 times the log of 1/2. Remember, you always move the exponent to the front and then you log it. All right, so in the calculator, what you're going to do from here, all right, so your next step right here, I need to divide both sides by log of 1/2 and get this over here, log of 1/2. So in your calculator, you're doing the log of 7/15 divided by the log of 1/2. So log, and you can just do 7/15 like this, or you can do the fraction bar, divided by the log of 1/2. An extra parentheses, that's okay. So I get 1.099. So I have this number equals t over 20. Now you're solving the equation for t. So if I want to get t by itself, I need to multiply both sides by 20. So I can take that number that's in my calculator that I got before and multiply it by 20. And that gives me the time, 21.99. And since we're in days, we can stay in days. These formulas right here work if it says hours, days, whatever, as long as whatever units you're in up here in the problem, that's the units you're going to get in the answer. Okay? On your compound interest ones, those work in years. So you're going to need to make sure that you always pay attention. I feel like there was a math lab question that I was looking at that talks about like the time is 3 months and you're doing like a compound interest formula or something like that. You can't put 3 in there. So if you're doing one of these compound interest formulas, that time that's in here, the time that's in here, you're going to need to do as years. So if it was 3 months, that's 1/4 of a year. So you would want to put 1/4 in as your time, or you'd want to put in 0.25. These other formulas, you're okay to use whichever units they're in. It doesn't matter if it's days or hours or whatever, especially on these half-life and doubling times. But on these interest formulas, make sure your time is always in years. Okay? All right. Thank y'all.